Okay, here's an application of the Pythagorean theorem where we're looking at an isosceles triangle and we want to know what the area is. So if we look carefully, we can draw a height here, and this height is also the altitude of the triangle, and it's also a perpendicular bisector because this distance and this distance are equal. Therefore, since these lengths are equal, we know that this is perpendicular and it bisects this side as well, which makes each of these 5. So with all isosceles triangles, that's going to be true. So before we find the area, we need to find the height of the triangle. And hopefully you can see that this is a 5, 12, 13 triangle. Because here's 5, here's 13. The hypotenuse is the longest side, and that's 13. So therefore, this is 12. So we would say h equals 12. If you don't recognize that, you would have to say, looking at just this triangle right here, or the other one, it doesn't really matter which one. If you look at just that triangle right there, where we have h, 5, and 13, 13 is the hypotenuse, so we would say 13 squared is equal to h squared plus 5 squared. This gives us 169 is equal to h squared plus 25, subtracting 25 from both sides. We get h squared is equal to 144, and square rooting both sides, we get h is equal to 12. So you could do it this way, or you can recognize the pattern and just write that. Okay, but that's not what they're asking for. They're asking for the area. So we know the formula for area of a triangle is 1/2 base times height, and this is where people also mess up. So be careful here. The base is the distance all the way across here. So that distance is actually 10 meters. So if we do this, it would be 1/2 times 10 times the height, which we found out was 12. Oops. So put a 12 in here. So it's 1/2 10 times 12. So I'm going to say 1/2 times 12. Those cancel and give me a 6 here. My answer ends up being 60 square meters. Okay? And that's all you needed to do. I'll show you what they did. So there's the sketch. Again, we know the length of the altitude is the height, and we know in an isosceles triangle the altitude to the base is also the perpendicular bisector, so it cuts it in half here. So again, they told us it was 10, but it's 5 and 5 there. So we use the Pythagorean theorem to get the height, and just like I did the long way, we get height equals 12, and then we find the area using 1/2 base times height, and we get 60 square meters. So we're going to do a couple more of these. If we look at this carefully, same type of problem. This is cut in half, so this ends up being 15 feet, and this also ends up being 15 feet. We want to see if there's a 3, 4, 5, or 5, 12, 13 here. This is 5 times 3, and this is 6 times 3, so there's no 3, 4, 5 there, or 5, 12, 13. So we have to do it the old-fashioned way. We're only going to look at one of these triangles as a right triangle because we want to find the height. So the height is right here, and so the hypotenuse is 18, so we say 18 squared is equal to h squared plus 15 squared, and 18 squared is 324, and that equals h squared plus 15 squared, which is 225. We subtract 225 from both sides, and we have h squared here, and on the other side we have 99. We're going to take the square root of both sides, and h is approximately, it should be about 9.9, but I'm going to do it real quick. Yeah, we get 9.95. So it's 9.95. we will just say 9.9. Now what I would suggest doing is keep this number on your calculator rather than using 9.9, because then your answer will be more accurate. We know that the area of a triangle is equal to 1/2 base times height. We know that our base, remember, is 30, not 15. So we'd say 1/2 30, and then we're going to write 9.9, but we're going to use the number that's on our calculator. Again, half of 30 ends up being 15, so we're going to just multiply what's on our calculator by 15. And if we do that, we get approximately 149.2. It's 0.24, but we would get 0.2 square feet. Okay? And there's our answer. Here's one more of them. Remember again, we've got 10 meters here and 10 meters here. Hopefully you recognize this is 13 times 2 and this is 5 times 2, so this should be 12 times 2, or 24 meters. And that's because it's a 5, 12, 13 triangle. We can go over that more in class if you're not getting it. 5, 12, 13 triangle. But we'll do it the old-fashioned way as well. The hypotenuse is 26, so we get 26 squared, and that's equal to h squared, where h is right here, plus 10 squared. So we get 676 here, and that's equal to h squared. Okay, we're doing a little bit more practice 100, with Pythagorean theorem, 100 from and both sides. I've seen a problem like this on standards tests and things like that. We get h squared. Good to pay attention to it. 576. We've got a 16-foot ladder that rests against the side of a house. H and the base of the ladder is 4 feet away. A lot of times they won't give you a picture. So now we do our area. You have to figure out what's my hypotenuse and what are my legs. Base times height. So in this case, if we look, the ladder is resting against the side of the building. It's therefore the ladder should be this hypotenuse, because that's 20, the ladder literally. And the height we said was 24. The 4 feet is the base of the ladder is here, the bottom, and it's 4 feet away from. So we get 10 times 24, which is from the building. So we want to know how high above the ground is the top of the ladder. That's this side right here. Oops. I'm going to do the setup. Sorry about that. But because we're going to get a decimal answer, let's close that. Our answer is 240 square meters. And we're done. Thanks.